Cosmic Sandbox, a comprehensive framework for nested realities. Introduction. The reality question that changes everything. Every second, your brain processes millions of pieces of information, yet you're consciously aware of only a tiny fraction. Your eyes perceive merely 0.0035% of the electromagnetic spectrum, just the narrow band we call visible light. Your ears detect only sounds between 20 Hz and 20,000 Hz, missing the infrasonic communications of elephants and the ultrasonic calls of dolphins. What if these aren't biological limitations but deliberate design constraints? What if reality itself has bandwidth restrictions? Important note: this represents speculative philosophy grounded in scientific observation, not established empirical fact. Think of it as an elaborate thought experiment using real physics as its foundation. From Plato's cave allegory to Descartes' evil demon, from ancient Hindu concepts of Maya to modern physicist Nick Bostrom's simulation hypothesis, humanity has persistently questioned the nature of perceived reality. Today, we're not merely asking, are we in a simulation? We're exploring what I call the Cosmic Sandbox framework, a comprehensive model for understanding potentially infinite layers of nested realities. The framework emerged from a simple observation: if our computing power has evolved from Pong to photorealistic virtual worlds in just 50 years, what could civilizations thousands or millions of years ahead of us create? And more crucially, how would we ever detect if we're living within their creation? This raises a profound epistemological challenge. Every method we use to investigate reality, our instruments, our mathematics, our very consciousness, exists within the system we're trying to understand. It's like asking prisoners in Plato's cave to analyze the cave using only the shadows on the wall. Yet this limitation itself may provide crucial clues about the nature of our existence. Today we'll explore how nested realities might function, why our universe exhibits peculiar limitations that could represent computational boundaries, and what this means for consciousness, free will, and the fundamental nature of existence. Before proceeding, a critical disclaimer: this represents speculative philosophy grounded in scientific observation, not established empirical fact. Think of it as an elaborate thought experiment that uses real physics as its foundation. Part 1. The Architecture of Layered Reality. The Hierarchical Reality Model. The Cosmic Sandbox framework proposes reality as a hierarchical system where each level can create simplified versions of itself while remaining largely blind to the complexity above. This creates what we might call an epistemic pyramid, a structure where knowledge flows downward but rarely upward. Reality Layer 2. Our created simulations at this level, we exercise complete control. Video games, computer models, virtual worlds, these represent realities we design from fundamental principles. We establish the laws of physics, determine possible and impossible actions, and set the computational boundaries. A character in Grand Theft Auto cannot spontaneously develop flight capabilities because we didn't program that possibility. What's fascinating is that conscious beings in reality too would experience their world as completely authentic and consistent. They would discover natural laws, which are actually our programming constraints. They might develop sophisticated science to understand their universe, never realizing they're studying code architecture rather than fundamental physics. Consider a concrete example. Imagine an advanced simulation where digital beings discover that their world has a maximum speed limit for information transfer. They might develop elegant mathematical theories to explain this constraint, never suspecting it's simply the processing speed limitation of our computer hardware. Their physics would be perfect descriptions of artificial constraints, yet feel absolutely real to them. Reality Layer 1. Our universe. This represents what we consider base reality, the universe of quantum mechanics, general relativity, and the standard model of particle physics. Yet our universe exhibits remarkably specific rules and limitations that bear suspicious resemblance to computational constraints. Consider these peculiar features. Information cannot travel faster than light. Why exactly 299,792,458 meters per second? In a natural universe, why such a precise universal speed limit? Energy comes in discrete packets, quanta. Why isn't energy continuous? Matter cannot be created or destroyed, only transformed. This resembles a closed system with fixed memory allocation. The Planck length represents the smallest meaningful distance. Below 10 to the power of -35 meters, our physics breaks down completely, much like reaching the resolution limit of a digital system. These constraints could represent the fundamental architecture of Reality Zero's simulation engine. The speed of light might be the maximum data transfer rate. Quantum discretization could reflect digital rather than analog processing, and conservation laws might ensure computational stability. Reality Layer 0. The base reality here exists, the ultimate mystery, the foundational reality where beings advanced enough to simulate entire universes operate under physics we cannot comprehend. What would reality zero look like? We can only speculate, but it would likely operate under principles that make our physics seem quaint by comparison. Perhaps they manipulate higher dimensions that we experience as mysterious forces. What we call dark matter and dark energy, comprising 95% of our universe yet remaining invisible, might represent computational infrastructure from reality zero. These could be the cooling systems, memory management protocols, and processing overhead required to run our simulation, visible to us only through gravitational effects but fundamentally inaccessible to our level of reality. The quantum database connection, reality zero's monitoring system. Here's where quantum mechanics becomes not just weird, but potentially revelatory. Quantum entanglement, Einstein's spooky action at a distance, might represent something far more profound than mysterious particle correlations. What if entangled particles function as reality zero's monitoring system, allowing instantaneous access to information across their simulated universe? Consider this possibility. Reality zero's beings observe our universe through what we might call screen zero, a comprehensive monitoring system that uses quantum entanglement as its information network. When particles become entangled in our reality, they might be establishing data links that allow reality zero to monitor specific regions or events without violating our simulated physics. This explains several quantum mechanical puzzles. The observer effect through computational optimization. When we observe a quantum system, the wave function collapses into a definite state. Traditional physics struggles to explain why observation matters, but from a computational perspective, it makes perfect sense. Why waste processing power calculating exact states for every particle when no one in the simulation is looking? Reality zero's optimization strategy might work like this. Keep particles in probabilistic superposition, unprocessed data states, until something within the simulation requires specific information. When observation occurs, the system queries reality zero's database through quantum entanglement, instantly accessing the correct state information. This isn't faster than light communication within our reality, it's a database lookup from outside our reality. Case study. The double-slit experiment reinterpreted. The famous double-slit experiment shows that particles behave like waves when unobserved but like particles when measured. Traditional interpretations invoke complex mathematics about wave-particle duality, but consider this computational explanation. When unobserved, reality zero's system doesn't calculate specific particle trajectories. It runs a wave probability algorithm that's computationally cheaper. Only when the simulation's inhabitants attempt measurement does the system access the quantum database through entanglement, instantaneously deciding which slit the particle went through based on reality zero's comprehensive knowledge of the system. The measurement doesn't change the particle. It triggers a database query that provides the information reality one beings are requesting. This explains why the observer effect seems to work retroactively and why quantum measurements appear random from our perspective while maintaining perfect correlation between entangled particles. Technical deep dive. The entanglement database architecture. How might reality zero's monitoring system actually function? Imagine every quantum particle in our universe contains what we might call database coordinates, unique identifiers that allow reality zero's system to track and manage them. When particles become entangled, they share database entries, creating instant information channels between reality zero and specific locations in our simulation. This architecture would require sophisticated optimization strategies. 1. Selective processing. Not every particle needs constant monitoring. Most matter can remain in low-resolution states until interaction with conscious observers or measurement apparatus triggers detailed calculation. 2. Hierarchical importance. Biological systems, especially brains, might have higher processing priorities. This could explain why consciousness seems to play such a special role in quantum mechanics. Conscious observers might trigger more intensive database queries. 3. Correlation management. Entangled particles share database entries, ensuring that measurements remain correlated regardless of spatial separation. From reality zero's perspective, distance in our simulation is irrelevant. They're accessing the same data regardless of where the measurements occur. The implications are staggering. Every quantum measurement might represent reality zero beings checking their monitoring systems. Every entangled particle pair might be a sensor network providing real-time information about events in our simulated universe. We're not just potentially simulated beings, we're potentially monitored simulated beings.